Welcome all. I am Dr. J Selvi, working as an assistant professor in the Department of Physics, Fatima College, Madurai. Today we are going to discuss about the topic lasers. Laser stands for light amplification by stimulated emission of radiation. There are three processes in quantum, that is as stimulated absorption, spontaneous emission and stimulated emission. First, let's see about what is stimulated absorption is. An atom in the ground state with energy E1 absorbs an incident photon of energy h nu and goes to the excited state, that is higher energy state with energy E2. There are two emission processes there. First one, it is a spontaneous emission. As its name itself indicates, the atom in the excited state, that is in the higher energy state, returns to the ground state E1, that is to a lower energy state, by emitting a photon of energy h nu without any external action or external agency. This process is called it as spontaneous emission. The next emission process is a stimulated emission. As its name itself indicates, it needs some external agency to trigger the electron or to make an atom in the excited state E2 returns to the ground state by the emission of photon of energy h nu. That process is called it as stimulated emission. There are some important terms to be noted in laser. The first term is the population inversion. The phenomena of making N2, that is the number of atoms in the excited state, should be greater than the number of atoms in the lower energy state. This phenomena or this process is called it as a population inversion. Next, the important term to be noted is a pumping action. The process to achieve the population inversion in the medium is called a pumping action. There are different types of pumping actions are there. One is optical pumping, the other one is a electrical discharge method, and the next one will be a direct conversion method, and there is atom-atom collision methods is also there. Depending upon the type of material what we are choosing, we have to adopt a particular type of pumping methods. For example, if we are choosing a solid state type of material, we have to go in for optical pumping. If we are choosing an gas type of material, we should have to adopt an electrical discharge method. And if you choose an semiconducting type of material for the laser action to perform, then the pumping method should be used, should be an direct conversion method. So let's see one by one. Optical pumping, when the atoms are exposed to light radiations of energy h nu, atoms in the lower energy state absorb these radiations and they go to the excited state. Electrical discharge method. In this method, the electrons are produced in an electrical discharge tube. These electrons are accelerated to high velocities by a strong electrical field. These accelerated electrons collide with the gas atoms. Next one is a direct conversion method. In this method, due to electrical energy applied in a direct bandgap semiconducting material, for example, as gallium arsenide, the recombination of electrons and holes takes place. During this recombination process, the electrical energy is directly converted into light energy. And let's see about now the characteristics of laser. These four characteristics features are the unique one when we compared it with the ordinary light. The first one, the laser has a high directionality, and lasers have a high intensity, and lasers have an extraordinary monochromatic nature, and lasers have a high degree of coherence. First, let's see about one type of laser, that is a solid state type of laser. There are different there are different examples for solid state lasers. One among them is the NDYAG laser. So this ND-YAG laser is a neodymium-based laser. ND stands for neodymium and YAG stands for yttrium aluminium garnet. That is, the formula is Y3Al5O12. It is a 4-level solid state laser. The diagram is given below. And a small amount of yttrium ions is replaced by neodymium ions in the active element of NdYAG crystal. The energy level diagram for NdYAG lasers is shown here. These energy levels are those of neodymium ions. NdYAG laser is a neodymium based laser. Nd stands for neodymium. It is one of the rare earth element. And YAG stands for yttrium aluminium garnet. It is Y3Al5O12. It is a 4-level solid state laser. The principle, the active medium NdYAG rod is optically pumped by krypton flash tubes. The neodymium ions Nd3 plus are raised to excited levels. During the transition from metastable state to ground state, a laser beam of wavelength 1.064 micron meters is emitted. The construction of ND-YAG laser is as shown in the figure. A small amount of yttrium ions Y3 plus is replaced by neodymium Nd3 plus in the active element of ND-YAG crystal. This active element is cut into a cylindrical rod. The ends of the cylindrical rod are highly polished and they are made optically flat and parallel. This electrical rod, the laser rod, and a pumping source, the flash tubes, are placed inside a highly reflecting elliptical reflector cavity. The optical resonator is formed by using two external reflecting mirrors. One mirror M1 is a 100% reflecting, while the other mirror M2 is a partially reflecting. The energy level diagram for ND-YAG lasers is shown in this figure. When a krypton flash tube is switched on by the absorption of light radiation of wavelength 0.73 micron meters and zero point 0.8 micron meters, the neodymium atoms are raised from ground level E0 to upper levels E3 and E4. The neodymium ions makes the transition from these energy levels E2 by non-radioactive transition. E2 is a metastable state. The neodymium ions are collected in the level E2 and the population inversion is achieved between E2 and E1. An ion makes a spontaneous transition from E2 to E1, emitting a photon of energy h nu. This emitted photon will trigger a chain of stimulated photons between E2 and E1. The photons thus generated travel back and forth between two mirrors and grow in strength. After some time, the photon number multiplies more rapidly. After enough strength is attained, the condition for laser being satisfied, an intense laser light of wavelength, approximately 10,600 Armstrongs of wavelength, is emitted through the partial reflector. It corresponds to the transition from E2 to E1. There are some unique characteristics, and what are all the characteristics of anti-YAG laser is discussed now. First one is a type. It is a 4-level solid state laser. Active medium here is a ND-YAG rod. Pumping method is optical pumping. We are used by using a krypton flash tube, and pumping source is xenon or krypton flash tubes. Optical resonator is two ends of ND-YAG rod is polished with silver. One end is fully silvered and the other is partially silvered, are used as optical resonator. The power output is approximately 70 watt. The nature of the output is pulsed or a continuous beam of light. The wavelength of the output beam is 1.06 micron meter. The advantages for this, it has a high energy output, it has a very high repetition rate operation, it is much easy to achieve a population inversion. The disadvantage